Recall from intermediate algebra or a previous algebra course, we have three methods to determine the solution to a system of linear equations in two variables. So the first method is graphing. The second method is substitution. And the third method is elimination. Let's review these methods. We'll first review the graphing method. So to solve a system of equations by graphing, remember that we'll just graph each equation on the same axes, and then we're going to look for any points of intersection. So the solution, or solutions, is any point or points of intersection. So remember, we've got three possibilities. If we graph the two lines, so let's say we have something like this, and they intersect in one point, then we have one solution. Our second option, if we have two lines that are parallel, so these are parallel lines, then they will never intersect. So that means there's no solution to the system. And we actually call this an inconsistent system. Inconsistent system. So that kind of makes sense. It's not consistent, it doesn't have an answer, kind of like an unusual one, so there's no solution, it's inconsistent. The third option is if we have two lines that actually coincide. So I could have a line right on top of another line. So it's the same line. So in that case, there's infinitely many solutions because those two lines coincide. They intersect everywhere. So in that case, we would have infinitely many solutions. Okay, now let's review the substitution method. For substitution, we want to first solve one of the equations, pick one of them, and pick one of the variables. So you're going to solve one equation for one of the variables. Then we're going to substitute, as the method suggests, we're going to substitute that expression for the corresponding variable in the other equation. We're going to substitute into the second equation. After we substitute, we're going to solve the equation for the value of that variable. And then we're going to substitute the value we found in step 3. So you find one of the variables first. So if it's an x and a y, you solve for x, for instance, first. Then you're going to substitute that x back into either of the original equations, and you're going to solve for the other variable, which could be y. So you can substitute into either original equation, or I think it's even better if you substitute into the isolated variable equation from step 1. And I'll show you in an example what I mean by that. And then finally, we always want to make sure we check our solution, and you don't want to just check it in one equation. You have to check it in both original equations. So if you get an xy pair, an answer, you want to substitute back in. It has to work in both equations.